All right, we're going to do section 9.1, page 445, number 21, which reads, the fourth and seventh terms of a geometric sequence are 3010 and 3,010,000, respectively. Find the first term, common ratio, and an explicit rule for the nth term. Now, I always think a good way to start a problem is to identify the things that we're given or the things that we know. So we are told that the fourth term, or A4, is equal to 3010. And we are told that the seventh term, or A7, is equal to 3,010,000. Well, we're also told something else important, and that is that we're dealing with a geometric sequence. A geometric sequence has to follow specific rules, as you read about and as we will talk about later in this lesson. And the most important rule is that an is equal to an minus 1 times r. A geometric sequence is a recursively defined sequence. The n term depends on the term before it. Well, what if we looked at the A2 term? That's going to be A1 times R. What about the A3 term? That's going to be A2 times R. So we can see why this is called the common ratio, because we multiply each successive term by R to get the next element in the sequence. But I have a formula for A2. It's A1 times R, and I can substitute in, then I end up with A1 times r squared. Let's keep going. If we want to write the term for A4, I've got A3 times r, but I have an equation for A3 that I'm going to substitute in. So I have A1 r squared times r. And when I do my math here, I get A1 times r cubed. Now you should see a pattern developing here. If this 4 over here is our n value, then our exponent up here turns out to be n minus 1. So really, we can write a general term here which says an is equal to a1 times r to the n minus 1, where a1 is going to be the first term and r is going to be the common ratio. Well, I'm going to use that. I'm going to go back over to my problem now, and I'm going to rewrite A4 and A7 in terms of this equation. So I've got A4, which I know has a numerical value of 3010, but I can also write it as A1 times r cubed. Here, n is equal to 4, which means that n minus 1 is 3, and n minus 1 is the exponent for my r. And I can do the same thing for A7. It has a numerical value of 3,010,000, but I can also write it as A1 r to the 6th. Here, n is equal to 7, so n minus 1 is going to be equal to 6. And this is great, because now I have two unknowns, A1, the first term, and r, the common ratio, and I have two equations. So I have a system of equations that I can solve for A1 and R. Now we could do some substitution, but I would prefer to be a little more creative and take this equation and divide it by that one. So I'm going to have 3,010,000, and I'm going to divide that by 3010. And on the other side, I'm going to have A1 r to the 6th divided by A1 r cubed. And now we can do some calculating and some simplifying. I can do the math on this side, and I end up with 1,000. And on the other side, I can do a little algebra. I can cancel out the A1s because I have one in the numerator and one in the denominator. And when I take r to the 6th divided by r cubed, I'm going to end up with r cubed. And this is very helpful because now I can just solve for r by taking the cube root of both sides. And of course, the cube root of 1,000 is 10, and the cube root of r cubed is going to be r. So I'm going to end up with the common ratio, R is equal to 10. Well, now I can go back to either of my equations up here and substitute in for R and figure out what A1 is. And I'm just going to take the simpler equation for A4 and use that one. So I've got 3010 is equal to A1 R cubed. So I'm going to substitute in for R. So I've got A1 times 10 cubed. And we just saw that 10 cubed was equal to 1,000. So I've got 3010 is equal to A1 times 1,000. And of course, I'm going to divide both sides by 1,000. And I'm going to have A1 is equal to 3010 divided by 1,000, or A1 is equal to 3.01. So we're almost there. The last step is to find an explicit equation or an explicit rule for the sequence. Well, I'm going to start with this equation up here because I've already done most of the work, and I'm just going to substitute in for A1 and R. So I can say that AN is going to be equal to A1, which is 3.01, times R, which is 10, to the n minus 1. And there we go.